Okay, solving absolute value inequalities is the first one. I'm sure that you're going to be watching on your own, so I'm going to try this pace. And please let me know if it's too slow or too fast or any other comments about sound, etc., because I don't know unless you tell me. So let's take a couple really basic absolute value inequalities. We'll look at x is greater than 3, and remember we're going to split these, so we're going to have x is greater than 3, x is less than negative 3. Now, we talked a little bit in the previous introduction video about why we flip that around, or just remember that we do flip it around on the negative 1. I tend to put the negative 1 on the left because it's going to match up the way it goes on a number line. So to decide where we're going to shade on a number line, we're going to test values on either side. 4 worked, so we're going to shade over there. 2 didn't work, so that tells us we're going in the direction of the 4. Negative 4, we'll try that. That works. Negative 2 doesn't work, so we're not doing in that middle part. So it's just the outside tails. Remember, that's going to be an OR statement. Then we'll look at the less than. So we've got x is less than 3. And again, when we do the negative version, we're going to flip the inequality symbol around. Then to decide where we're going to shade, we'll test a number. 4 is less than 3, no. 2 is less than 3, yes. So we know we're going to start shading on that side of the 3. We know we have an open dot. I just did all these with open. Try negative 4, that doesn't work. Try negative 2, yes, that works. So again, we're going to shade to that side. So these guys are going to connect, and we're going to get an and looking one. And so we don't write it with the word and. We write the compound inequality for an and one with the x in between. And if you put the negative on the left when you do these, 90% of the time it's just going to look just like the number line. So let's do a little bit review on equality 1. So absolute value of x is equal to 3. That one is no solution because the absolute value is always positive. It means the distance from 0. So there is no value that'll work to say that it's negative 3 units from 0. We can't put anything inside that absolute value bars to make that a true statement. So now let's look at some inequalities with negative signs, because they are a little bit different. So let's try greater than negative 3. Let's just test some values in there. Absolute value of 0 greater than negative 3 means 0 is negative 3. That's true. Let's try another number to the right, a bigger number. 2 is greater than negative 3. That's true. Let's try a bigger number. 5 is greater than negative 3. That's true. So notice it's that whole direction that way that's going to get shaded. Now let's try some negative numbers. Absolute value of negative 1. Well, that's 1. 1 is greater than negative 3, so that's true. Bigger, or number that's further away from 0. Absolute value of negative 9 is 9. That's true. So when you have an inequality that's a greater than, it's going to be all real numbers. When you have less than, it's a different story. So let's again test some numbers. We'll try 0. Absolute value of 0 is 0. 0 less than negative 3? No. Try a bigger positive number. Absolute value of 5 is 5. That's not true. Absolute value of negative 5? That's 5, so that's also not true. So guess what? Nothing will be true. There's no solution. Again, we can't put anything in there to get out anything less than negative 3, because anytime we have something inside the absolute value bars, it's got to come out positive, and no positive number is less than negative 3, or less than any negative number. So those are special cases. You won't see them that much, but you got to be on the lookout so you don't do a bunch of work that you don't have to do. And that's it, whether there's just an x in there or whether there's a big ugly equation inside those bars. Look inside, look to the right. If it's a negative, you have two choices. It's either all real numbers or no solution. Okay, and then just a couple basic ones. We'll try one that's a greater than. And I'll put equal to this time. Again, that just means it's going to have a closed dot. And we'll do a less than. So we're going to split this into two. Greater than or equal to 10. And then do the negative version. We'll flip the inequality symbol around. And just go about solving this just like we would solve anything else. Okay, so we end up with x is greater than or equal to 3. And then we'll solve the other one. And this one's going to come out to nice pretty numbers. It just happened to be the numbers I used. And so that's going to be an OR. Those guys point away from each other. If I put those on the number line, easy to see they point away from each other. Okay, so maybe we can start to see a pattern here. Try this one. And I'm telling you what the pattern is. If you have a greater than, it's going to be an OR. If you have a less than, it's going to be an AND. So this one we're going to go about our business. If you forget that and you just go ahead and separate them and solve it, you're going to get to the same place, just like I did on that first slide. But if you recognize it's going to be an AND, then you don't have to do the two separate equations. You can just write it as an and do it as an and. So we have fraction answers. So, negative 7/8 is almost negative 1. 17/8 is 2 1/8. So there's our and. So just a reminder. Here's a little trick or, wordplay that people use. Greater than and less than. So that's one way to remember it. I remember it a different way. I think about greater than ones, they point outwards, so it's going to be an OR because they point away. Those are the outy ones. Right? They look like that. The less than ones, they point towards the middle. They point towards each other. So that's going to be the AND type. So hopefully one of those two tips on the top or bottom helps you. And again, if you forget and you do an AND by separating into two, you're going to still get the same answer. It's just a little easier if you notice it ahead of time.